Okay. All right. Just form a circle because we need to grab hands. Okay.
Come on, ladies, get closer.
Okay, grab hands. Put your hands together. And there. Okay. Everybody grabbing? Tell me if you can feel anything. Okay, can you feel anything? Oh yeah, you can feel it. Okay.
Don't let go, Sasmat.
Oh no, don't do this.
Okay, so that feeling that you have right there, your muscles are electromechanical, so they turn electrical energy into mechanical energy, and there are certain people on the planet who have taken this phenomena right here and put little electrodes on for $300, and you can now walk around and your tummy is going like that, and you're working off the muscles. So come look over here. I want to show you.
And they were marketing it for
weight loss.
Weight loss.
Yes, body sculpting.
Yeah. Building up your six-pack as you walk.
That's right. Okay, I need...
Girls, I seem to be taking pictures of the boys all the time, so can I get you a little bit more enthusiastic? May I? Because I hate to be sexist.
I'm going to show you one of my favorite things. Having to do with charge separation. Any idea what it is? Charge separation. What time do you guys actually have to leave?
I think our next event's at 12, yeah. But I will be leaving around about 1:30, maybe 1:45.
How long did it take to get here? An hour?
Yeah, something like that.
Somewhere around that?
Traffic was good. Only service.
So, some fun. So, here we're using unequal charges in order to get mechanical force. As you study, you can those in. So, oh yeah, ready? Okay. So one of the things about engineering is you're able to use physical processes in order to do something that maybe nobody else has thought about. So the nice thing about physics is it teaches you the fundamental science. Any idea what that is? Just search electrostatic. That's exactly right. It was an electrostatic motor. Normally we use a magnetic motor, but because we switch, we'll have a magnet here, and we move another magnet near it, and then when it gets near, we change that one from from north to south, and it goes around and around and around. So it's all done. We do exactly the same thing with the electric field here. So we have high voltage positive right here. Like charges repel each other, so we end up with that being charged positive because it's connected here. Then the air around it, that little point right there is vitally important because air molecules just move around, touches that point, rips an electron off because this is high positive, air is neutral, This then has one less electron. This is positive, that's positive because of the one less electron. It goes flying off onto that plate there. There's a few hundred billion, few trillion of them on there. They put the charge on there, so it's now positive. That's positive, so it repels. The next one gets charged up, it gets repelled. And when we get all the way over here, this next one starts getting charged up while we rip the charge off of one of the three plates. So if you look here, three plates, just like a water wheel. You put the water on one side and not on the other. You end up with more charge on one side than the other, and off it goes. So, one thing I'd like to say, how many people have a microscope? I have one. Yeah, and sure, lots of people use the dining room table for eating and things like that. But it's great for holding microscopes and things. But my microscope, even though it's a few $100s, is not as good as we have at uni. And if you have a passion about anything, and you go, you know what, I can't afford a $10 million electron microscope. I can't afford a $1.5 million furnace in my fabrication lab at home. So what I'm going to do is go to